So here's that promised help on the t-shirt project, part 2. When you got through the first part of it, what you came up with was we imported some data that I gave you, and then you came up with a revenue function and then answered some questions related to that. Things that you had to do as well is find the linear, quadratic, and exponential models for that demand data. And in the end, we're going to choose the quadratic. Another thing you want to note is that when I do this problem here in a second, I'm going to change something on our project. It says down here for cost, we're going to add 20% for order variation, size variation. I might change it to 10. It just gets a little too much. I think that's more than necessary. So we'll add 10% to that and then allow you to answer questions from there. And then we'll use this tabular data here. I have pulled some information that isn't necessarily what we'll use for our class. So for instance, here's some old demand data, not ours from our class, but I'm going to use it as an example for you guys so that you have your own still to play with, but I'll use that data. Again, different from yours if it looks different, it's supposed to. And then if you look at sheet 2 here, I'm going to pull in some price data. I did 3 colors, I think, as I pulled the data from it. I think I'm missing, yeah, it's got them all in there. But if you look at our custom thing here, I've got 3 colors in here. And I'm actually going to have you guys go about doing a 2-color shirt. So I think I'll make all that clear when I send out the additional information. But now as you're watching the video, I'm just playing around with data that you will not use as an example, and that allows you then to try and do it on your own when you get to your data. Okay, let's go. First thing we got to do is the things that you have are revenue and demand, and I hope you filled in all these pieces because you grabbed our demand data from class and you did a scatter plot. And I'm going to still do that because I need it still today for answering some other questions. So what you did is your regular scatter plot, and you want to make sure that your X is market number of people, and then your Y is your dollar amount on the side. And then when you format or add a trend line, you go through and you can choose your different kinds of trend lines to fill in the table that I gave you guys. But ultimately, for our purposes, I'm going to go ahead with using quadratic, that polynomial order 2. And so that's the part I'm going to pull into my equation. Now this is the demand data from that chart. I'm going to zoom in a little bit so you guys can see what I have. And I'm going to show you guys how to pull this all together to make a profit function and to use Desmos to make that even more dynamic and pretty cool looking so you can answer questions later on without a whole lot of struggle. Okay, so there's our demand data. Cost data is using this chart we have at the bottom of your sheet. And if you'll notice again, I pulled up the 3-color. You guys are going to do 2 colors. So I might even put up here the 3-color example, different from what you'll do. And the price we actually get a regression for as well because it's dynamic. So for the number of shirts as they increase in order, you guys see a price drop because you're ordering in bulk. So I'm going to see, here's the same process of getting a regression. You add a trend line, and I pick, this time I'm going to ask that your cost functions are all of the version called a power function. And the reason is this all, I'm picking things that are easy for you guys to do derivatives of and utilize the calculus stuff that we've gone through. So that's the power function. That's the example for my data. I'm going to make that bigger so you can see it. Okay, so that's what I'll show you how to incorporate that into getting cost, as in the profit is revenue minus cost. So I'll keep these things handy. I think I have both ready to go on my sheets here. Again, demand data we have is different, but you make a demand equation. You've already done this. And then you're going to make a cost function from picking not the data that I did, the 3-color examples, but you're going to do number of pieces, which is you're going to use only the left-hand number in each of these in this left column. And you're going to do 2-color data. So instead of mine, you're going to use I use the 3rd column. You're going to use the 2nd. To Desmos, what we do is we pull these equations together. So I'm going to try and get them so I can see them off the screen here. Voila. I think I can see this one as well. If I go over just a little bit, make that work. That should be close enough. Okay. So when I put this into Desmos, you have the first thing you want to come up with your demand function, little p, and graph. You don't want to graph it per se, but we will use the equation of it. And that's this quadratic 8e to the negative 0.9x squared. We haven't talked about the meaning of that. That actually is scientific notation for moving the decimal from, instead of being 8 you're going to move the decimal 8.0, you're going to move it to the left 9 spaces. And so if I do that, that actually makes 8 zeros and then the 8. This expression right here that I just highlighted is the same thing as 8e to the negative 9. It's me moving the decimal place 1, 2, 3, 4, 5, 6, 7, 8, 9 places over to the left. And then x squared, so that's my piece minus, and then I'm just going to write this whole thing in. I'm going to type it piece for piece so you can just watch me do that. If you want to find your own data and type it in, that's fine as well. 35.623, got it. And that's my demand curve. For revenue, big R, and I would label these appropriately, don't cut any corners. We just take that times x, so I can actually put little p of x in there and then call it good. So that way my equations are dynamic. Now it started to graph this, but it definitely goes off the charts, and that's something you want to be able to find as well. I'll give you tools for that. This is where we've been so far. You got demand, took it times x to get your revenue, and maybe you've graphed this and found where it fits. Well, the next piece is we need to get cost, and that's from the t-shirt. When you go to print t-shirts, there's two things involved. There's the cost of the shirt itself, and then there's the printing costs. And what I have a table of is the printing costs, the amount what it costs to put the, draw it on there, and the ink and, profit. Obviously, they need to make money as well. But it's not the cost of the t-shirt itself, so I'll incorporate that later. So here are the data that say, depending on how many order, we're ordering more than that. So this model that we have is actually helping us predict, as we order more shirts, since I'm off the charts, this equation 7.22 x to the negative 0.264, this power function I came up with, that's our approximator for the price cost to us. Okay, so I'm going to call this little c of x, and there'll be a big C. And little c of x is 7.2266x to the negative 0.264. Okay, so we get that, and there's no reason to graph that at all, demand either, so I'm turning off those two graphs. But that's our data. That's what our regression came from our data. Now we can use it anywhere we want, and it's called little c. Okay, so big C cost, the actual cost to us, uses this little c of x, but I want to incorporate one more thing in there. So what I'll do is it's like using little c of x, that's part of it, but we also have the cost per shirt, $2 to us for every shirt that we have. So it's not just the price of printing on the shirt, it's also the cost of $2 per shirt that we just add to it. So that's our big cost function. Again, I don't need to graph this, so I'm going to turn it off. And then finally, this allows us, we've got revenue, and we've got big C cost. We can actually go about, the profit model is ready to go. I just have to type these in. So R of x minus big C of x, and we have, what's our profit function? Now I'm only going to tweak this ever so slightly, but this is it. We've been able to take our data that we have for the price of printing the shirts, which is that 7.226x to the negative 0.64 model that we came up with, and then we added to that just a little bit, $2 per shirt, so that's a 2x. That's our total cost to us. Revenue, we just knew we got our demand data times x. We're good to go. Now, when we want to kind of make decisions, we're all about finding the peaks of these, the highest values. And the easiest way to go about that with this is if you go into that wrench and you go into the x-axis, if you add a few zeros kind of slowly on there, you'll start seeing a little more view. Might take it out 2 or 3 notches. I'm at 17,000 on the x-axis, and same thing if you start adding zeros to the y-axis, the y upper piece, you'll start seeing the peak emerge. And if you get a little bit of curvature in there, then you're probably getting pretty close. You can do it by hand from there. And that is a pretty good picture of, if you can, turn everything off except for profit and revenue, because those are where our conversations begin, is where profit and revenue have their various peaks. And if you already want to know what the peaks are, if you want to get into it, if you click on each graph, the peak automatically shows. And if you click on that point, it'll darken and it'll stay. Click on the other graph, peak shows up, click on the point, and it'll stay. And now we have a blue revenue curve and a orange profit curve, which is less because we've subtracted cost from it. And for each of those, then our job is to find out how much, what the price is that we'll set our shirts at. Remember what X stands for on the X-axis. It's our number of shirts, and Y stands for money. So what you're seeing is an output of money, like $238,000 and $269,000 respectively. But if we want to find out the price of each t-shirt, that's back in our little P of X demand function. So if I ever want to know the price that corresponds to the peak on the orange profit graph, I would have to type in that 15,012 units. And we'll go whole numbered units. We don't need to deal with fractions. What comes out is a price per shirt, so $17.90. If I want to do it on the revenue curve, the blue one, see what that price is that achieves that maximum revenue, I would need to insert that 16,091 and see the price that comes out, $16.77. We're already seeing an interesting dynamic where a higher price in that $17.90 is the benefit that benefits your profit versus a lower price of $16.77 is one that gives you a higher amount of revenue. Obviously, we're looking at the profit as our primary goal, but that discrepancy is interesting and will be when you answer some other questions later. This is the setup for which you can answer all your questions, having all this in place. The only last thing to incorporate, and it's really quick, is that additional 10% order we want to put in because we want to make sure that we have variation, size variation, and that's going to be a cost to us. We don't anticipate selling that additional 10% of shirts. If you get lucky, you do, but it's only going to affect our cost. And so what I'm going to do is see my big C cost function here, and I'm actually on the orange profit thing. Inside there, what I'm going to do is I'm going to put a 1.1 in front of that X, and what that does is it increases the X that's going into the cost function. X again is number of units by 10%. And so what we see in our profit, there's a little bit of a change. If you look at my profit now maximizes at, instead of, what was it, 1512 before, now it maximizes at 14,905. So I would need to change this number down here to see what the price is that associates with 14,905. If you want to round it up to 906, that's fine. And there's extra one in there. There, 14,906. Now we're seeing a price of about $18 that would maximize it because I'm dealing with that additional cost for ordering additional shirts for size variation. Okay, now the sky's the limits for you to take this wonderful graph and the answers that are available to you already. We're going to correlate, of course, the calculus required to go with it to find those peaks and valleys and show that it gets the same results. And then there's some additional questions where we change up a few of the items in here later on. And just by looking at these graphs and shifting them around a little bit and plugging in some numbers, you'll be able to answer those questions pretty fluently. All right, hope that helps. See you guys on